Hello class, this is Michael Elmes. I'm going to be covering a couple of problems from the Test 2 review for Math 145, and we'll jump in with number 18. You get $4,000 now, you deposit it into an account, it earns 8% interest. Find the balance after 3 years. All right, so it looks like we're going to use one of these two formulas, okay? If we compound continuously, you'll use the formula with this PERT. And the other formula is when we have interest, it's compound either monthly, weekly, daily, quarterly, etc. Right? So n would be 52 if we compound weekly, n would be 12 if we compound monthly, 365 if we compound daily, and 4 if we compound quarterly. R is the interest rate written as a decimal. P is the amount you start with now. A is the amount you'll have in the future. And this value for E, if we compound continuously, it's just a number, right? Just like pi is a number, 3.14, etc. E is just a number, right? 2.718, etc. All right, so if we look at the first problem, let's move this over. How much will we have after, if we compound monthly after 3 years? So for letter A, I'm gonna write this in a better spot. All right, so for letter A, right, the amount in the future is the amount we start with now times 1 plus the interest rate was 8%, so I write 0.08 divided by the number of compounding periods. Since we compound monthly, n is equal to 12. And that's raised to the 12 times 3 years. Okay, again, that's coming from this formula here. Okay. So we have to enter this into our calculator. So here's the formula written out. I entered this into my calculator, and here's a screen where it's a little bit bigger. So again, before you press enter, think about the reasonableness of your answer, right? If I put in $4,000 and I take it out 3 years later, I should get back my $4,000 plus some interest. In this case, it looks like the interest is about $1,080 and change, right? So that's my answer for letter A. Let me just write that out. I took the liberty of rounding, right, to the nearest dollar, so I got $5,081, right? That's my answer for letter A. Letter B, essentially we're doing the same thing, except instead of compounding monthly, right, where n was equal to 12, right here, we had n equals 12. Oops. Let's try and write that a little neater. n equals 12. Now, weekly, n is going to be 52. Okay. Right, so I rewrote that, right? So monthly n equals 12, weekly n equals 52, daily equals n equals 365. So to answer letters B and C, we're just going to use the same equation except change the value for n. So I wrote those equations out, right? The only difference between letter B and C, or really letter A, B, and C is A, we compound monthly, which is 12 months in a year. B, we compound weekly, there's 52 weeks in a year, and C, we compound daily, there's 365 days in a year. So I'm going to enter this into my calculator. So I've entered those three equations into the calculator, right? Here we compound monthly, weekly, daily. Notice how my n's have changed, but everything else remains the same. My P was 4,000 for all three of them. My R was 0.08 for all three questions. The only thing that changed was the n, the frequency of the compounding, right, from 12 to 52 to 365. Now, as soon as you see the word continuously, that changes everything, right? As soon as you see this word, you know you're going to this formula instead. A equals PE raised to the RT, okay? So for letter D, we're going to write, so I put that into my calculator, right? The 4,000 E to the RT, right? PERT, I press enter, and I get $5,085 basically. All right. So I'll just write 584. Well, And I just want you to notice that it looks like when we went from compounding monthly to weekly, instead of getting $5,080, we got $5,084. So compounding more increased the amount we get by, it looks like, $4. But then when we compound from 52 to 365, the increase wasn't that much, right? From 0.05 cents to 86 cents. And then compounding continuously, we went from like 86 cents to 99 cents or $1. So the more you compound, it seems like the benefits of the compounding start to wane as the compounding period gets really large. As n gets really large, the benefits from compounding begin to wear off. Okay, and let me just write in my answers here. So these are my answers for A, B, C, and D. Okay, and again, in my class, I'm going to give you these formulas. You don't have to memorize them, but some of your teachers might ask you to memorize these formulas. Not a big ask. Number 19. So for 19, it looks like we need two equations here, right? The first one is you deposit $4,000 into an account, right? So the amount in the future, the amount in the future equals your $4,000. And its annual interest is 6%, so it's 1 plus 0.06 over 1, because annually, right, so this is the equation for you, right, 4,000 at 6% compounded annually, right, so there's 1 year in the year, so n equals 1 for annually, right, n equals 1. And then you have a friend that has 4,200, and they compound continuously, 5.5% continuously. So we use the PERT equation, 0.055 times x. And we want to know when will these things be equal. So what we need to do is graph both of these and get the intersection, all right? And again, why did I use this second equation with the E? Because as soon as you see the word continuously in a problem, this is the equation you're going to use. So for 19, it says your friend is getting 5.5% compounded continuously, so I use PERT. So we're going to graph both of these equations and see where they intersect. So after I enter the two equations into my y equals, right, I get something that looks like this. Right, I wrote 1x, but you could just write x. I wrote 0.55x, 0.055x for the second equation, right? So this looks, right, like the equations I wrote. Now my window is going to be tricky because, you know, we're starting at 4,000 and we're going to keep going up until there's an intersection, right? So I don't know how many thousands of dollars that's going to take. So when I go to my window, I went from 0 to 20, right? So I'm thinking somewhere in between 20 years, there's going to be an intersection. I don't know when, but within 20 years. And then I brought my Y-max thinking that there'll be an intersection somewhere before at least $10,000. I press graph. Now, that's not a great looking graph, but somewhere in here, it does look like there's an intersection. So I'm going to press second and trace. Number 5 for intersection. Enter 3 times. 1, 2, 3, and it's going to show me the intersection happens at, we'll call that 15. Okay, so it will take 15 years for the balances to be equal, right? So it says, will your balance ever equal your friends? And the answer is yes. It will take about 15 years. Okay, and our method would be the graphing method, right? We graphed it. Okay, so just one more time, the answer is 15, right? About 15 years, your balance will equal your friend's balance and then actually be bigger than your friend's balance, okay? And the method we used was the graphical method, okay? So I'm going to stop here and then we'll do one more video to finish up the Test 2 review packet. Thank you for watching.